Hey, welcome to 8.2 Part 1, Lines and Slopes. In this first video, we're just going to talk about a bunch of important background information you need to complete this lesson successfully. So I'm going to give you several formulas, talk about lines, talk about special lines, and talk about slope. Make sure you write everything down and put boxes around important formulas. So in 8.2 and 8.3, we're going to be talking about linear equations. A linear equation is a graph that makes a straight line, or a straight line. Specifically, there's three formulas we can use for linear equations, and these three formulas we're going to use for 8.2 and 8.3. So a linear equation could come in standard form. Standard form is when the x's and the y's are on the same side for your equation of your line. Ax plus by equals c is the standard form. A, b, and c don't actually give us any important information for graphing, so this one is really only useful when you're finding your x and y intercepts. The next type of line format is called slope-intercept form. I'm just going to throw it out there. I bet a lot of you remember this one. This is the one like people always remember from Algebra 2. This is your y equals mx plus b that you may remember. And in this case, these variables actually do mean something important. So the m in this formula stands for the slope of our line, and I'll talk more about slope in our next video. And b is the y-intercept. The third form for an equation of a line you need to know is called point-slope form. Point-slope form is useful when you're trying to create equations of lines, which is what we're doing in section 8.3. For point-slope form, it looks like y minus y1 equals m, and then in parentheses x minus x1. And m is still the slope. I want to give you some background information about these y-intercepts I'm talking about. So let's draw a little diagram in your notebooks. We talked about this in 8.1 where I've got my x-axis and my y-axis, aka y is in the sky. We talked about, let's say I had a linear equation, so that means I've got a line. Where my line touches the y-axis, that's called the y-intercept. So when I say y-intercept, I specifically mean a point that's on the y-axis, not the x-axis, the y-axis. And that point is always going to have an x value of 0 because it's always just up or down. It's never have traveled left or right from my center. So that point right there always has an x value of 0, and then we don't know what the y value is. It could be anything depending on our situation. In this example I'm making, it looks like it's at 0, 2. This point down here where it touches the x-axis, that's called the x-intercept. And the x-intercept has a y value of 0 because it never will have traveled up or down on the y-axis. It's always just right on that line. So that's kind of some key information for you there. The next key piece of information I want to talk about is slope. So I look at this line, I can see that it's sloping downwards when I look at it from left to right. Specifically, a slope of a line measures how steep the line is, and sometimes it's also called the rate of change. Do write those words down. Rate of change is how slope may be talked about when you're taking the ACT test. So we want to work on that a little bit. I'm going to give you some word problem situations later. We're going to practice finding slope, but it's going to say rate of change, but it means slope, okay? And the slope is, again, how steep the line is. How steep the line is. So how slanty it is, basically. And I bet you remember this from your past also. In middle school, you learned about slope as rise over run. Then we got a little more sophisticated, and I talked about y's and x's. And when I say rise and run, rise is how far up or down it's going, and run is how far left or right it's going, okay? So how far up or down it's going would be represented by my y values. So the formula is y2 minus y1. On bottom of the fraction, x2 minus x1. And why don't you set that equal to m? M is always the variable we're going to use for slope. So it's the change of my y's on top divided by the change of my x's on bottom. And you may or may not remember this. x1 and y1, and I didn't say this earlier, but same thing for point slope form. It's just a numbering system. It's just some way of us knowing that that's point 1 and that's point 2. We're not actually going to do like y squared or something. It's totally different than y squared. It's y sub 2 just to mean it's from point 2. We've got one more thing to talk about with our key pieces of information here, and that is two special lines. So we're going to talk a lot about graphing today, tomorrow, and the next several days, all through 8.2 and 8.3. But there's two special things I want to mention just right away, because these are tricky. So you want to write these down in your notebook, and again, put a box around them. Horizontal lines and vertical lines have kind of weird slopes and a weird equation of a line. So these are always a little bit tricky. All right, so the horizontal line example I'm going to give you is going to have a line. So horizontal means straight across from left to right. It's going to be straight across from left to right, and it goes through 1 on the y-axis there. So what's true about horizontal lines? Well, if you look at this, my y values, let's say I picked 2 points here, it's not increasing at all over the y. So the y is 0, and over x it is increasing. So the slope is 0 over some number, which is just 0. So the slope for a horizontal line is always 0. Now here's the tricky part. If I was going to give you an equation of that line to graph, the equation of the line is always y equals a number, and it's always the number it passes through. So this one passes through 1, so it's y equals 1 for my equation of my line. Next, vertical lines. We're going to draw a vertical line right at -2 here. A vertical line has x is 0 if you're trying to find your slope, and you can't divide by 0, so the slope is undefined when you have a vertical line. And let me just give you an example. Let's say I had 3 divided by 0. That's undefined. You can't have 0 on bottom. So if you're trying to find slope and that happens, that's when you know it's undefined. The equation of this line is always going to be x equals some number, and you always do the number it passes through. So this one passes through -2, so it's going to be x equals -2. Now this is a part that's kind of hard to tell apart. So what I do is I think, okay, if it goes through the y-axis, it's y equals a number. If it goes through the x-axis, it's x equals a number for the equation. We're going to talk more about this as the section goes on. Thanks for listening.